Today we're going to talk about pipes, the pipe system call, and how we can make a better version of popen. Hey everybody, welcome back and thanks for being here. It's been really fun to watch the channel grow and I really appreciate all of your support. Today we're talking about pipes. I talked about pipes earlier in a video back in 2018. I'll put a link below in the description in case you missed it, but I wanted to revisit the topic today because in that video I talked conceptually about pipes and gave you some pointers on how you could use pipes, but I didn't really get under the hood and talk about the pipe system call, how pipes are created, or popen and how we could improve on it. And hey, pipes are things that a lot of us use every day, but we take for granted. We run our programs and they have 3 pipes, standard out, standard in, and standard error. But often, especially as new programmers, we don't think about how those pipes got there. So in today's video, I want to try to add some pieces to that puzzle. And of course, if you're looking for source code, all source code is available through Patreon. So now let's kick things off with a little bit of code. So I'm starting out here with a few files you can see over here on the left. I have a test program. It's really a simple one. Let me just take you through it really quick. The whole point of this program is to use all 3 of our standard pipes. So it first prints out a message to standard out, then it reads anything that comes in from standard in and prints that out with a little input prefix so that you can see that we actually modified that input. And then at the end down here, it prints out something to standard error just so we have output going to standard error as well. Now, if you're not familiar with standard error, it is a separate pipe and it's typically used for errors. And this can be really useful because it allows us to separate the normal output from a program with any errors that it produces. But yeah, so this test program, really there's nothing fancy here, but it will help us see what's going on as we play around with pipes today. So next, let's make a simple example that is going to use popen to run our test program and grab its output. So here in this case, I'm just going to use popen. And I'm going to give it a command. So popen is going to run a command. In this case, we're just going to run our test program, but we need some input or our test program is not going to do anything. So let's use the echo command to pass in some text and we'll pipe that into the test program. Okay, so this is basically going to run this command and we want a read pipe here. So we're going to read whatever goes to standard out. So that's pretty straightforward. Then let's make a buffer. And this is just going to hold the data that we read in. So let's declare a constant here just to try to use good form and not use a bunch of magic numbers. And then down here, we will just have a little while loop. I'm just going to use fgets to read into my buffer up to buff size characters from my pipe. And we'll just keep doing as long as there's data to read, we will just print it out. So here we're just going to add a prefix again, just so we can see who's printing what. And we will print out the thing we got. We'll add a new line at the end, print out buffer. And then down at the end, we will call pclose to close our pipe. So that's pretty straightforward so far. I also have a make file. It's all pretty standard, just like you've seen in my other videos. Be sure to check out my make videos if this doesn't feel standard to you. But just to make sure that things are working, let's come down and compile our programs. Ignore the error, we'll come back. That just means there's some code that we haven't actually written yet. So if we run our test program, okay, you can see, well, there's no input, so it's waiting for input. So let's come in here and do what we did up above, pipe in some text to it, and you can see that it takes that input, prints it out, and it prints out, by the way, this is standard error to standard error. So this all looks okay. Okay, so that's working. Now let's our plain popen example, and we'll run that, and that looks good too. We're basically able to get the output that was produced by our test program in response to the input that we gave to it in the command in popen right here, and everything gets printed out just fine as we expected. But one thing at this point you might be thinking is, hey, I got standard out, but how do I get standard error? Because clearly that just got printed out on its own. We didn't capture that. Or how do I read from both standard out and standard error? Or if we really want to go crazy, can I have a program that accesses all 3 standard pipes so that I can write to standard in and read from both standard out and standard error? Well, naturally, the answer is yeah, you can. The popen function is a bit limited and only lets us get 1 pipe at a time, either standard in or standard out. Standard error is totally neglected, but it's okay because today I'm going to show you how to expand it, and hopefully you'll have a better understanding of how pipes work by the time we're done. So specifically what I want to do today is to implement my own version of popen. And I'm going to call it popen3, and it's going to return not one file pointer, but 3 of them so that I can access all 3 standard pipes. And for you Python and Ruby developers out there, this may sound familiar because Python and Ruby have library calls that are similar to this. Now you may have noticed that I have a few additional files in here that I haven't talked about yet. Okay, let's take a look at them now. popen.h, we're just going to have some interface information. popen.c is where our actual popen3 function is going to be. And then there's also this popen3 example down here, which is where I'm going to put another example that's going to actually call our popen3 function. So let's get some preliminaries out of the way. There are a few different ways that I could implement my popen3 function. Today I'm going to write it like this. So basically what I'm going to do is I'm going to type def a struct. I'm going to return a struct. And this struct is going to have a bunch of file pointers. It's going to have one called in, one called out, and one called error. And we're going to call this standard pipes. So nothing too complicated. We're basically just passing those in. I'm also going to include standardIO.h because that's where this struct right here is actually defined. And so I'm going to define my popen3 function like this. We're going to return a struct. It's going to be one of these standard pipe structs that we just defined, and we're going to call it popen3, and we're going to pass in a command. So this is just like popen, except we're not going to tell it whether it's read or write because we're just going to get all 3 and return them in this struct. So we didn't need that argument. Okay, now let's go look at how our example code's going to work. We haven't implemented popen3 yet, but we know what it's going to look like. So let's jump into the example and see how we want to use it. So this example is looking very much just like the example you saw before. So we call popen3 with a command. I'm for now using the same command that I used before. We're going to change this example a bit as we go. Right now, we're still just getting standard out. And then notice down here, the only thing that really changes is I'm returning this standard pipe struct. I'm calling it mypipes. And then down here, I'm going to read from mypipes.out, so the standard out element, as opposed to just pipe like we did before. And then we'll still close mypipes.out down here. Now notice again, I'm focusing on standard out. We're going to get standard out working first, and then we'll expand it and include standard in and standard error. Because we basically handle these in all very similar ways. And so I figure we can focus on one, and that'll help you get a conceptual idea of what we're doing, and then we'll build it out from there. Okay, so now let's jump over and get started actually implementing our popen3 function. So let's start out by declaring our result struct. So we need a standard pipes, we'll call it result. And I'm going to initialize that like this. Basically, we'll set everything to null. And I'm doing this because that way I can return this early on if there's some kind of problem. In the same way that we would return a null file pointer, we're just going to return 3 null file pointers in a struct now. And again, there are other ways we could handle this. This is how I'm handling it today. It's not necessarily the right way. Definitely let me know down in the comments if you think there's ways that I could improve this. Now we're going to need a pair of ints. Okay, I'm going to call this sout pair. It's the pair of integers that are going to represent my pipe for standard out. And I'm also going to define a process ID, a PID, and we're going to need this later on because we're going to create a new process. Okay, so now we have our basic variables we're going to need. The first action of our function is going to be to create a new pipe. So we do that with the pipe system call. And we pass in our pair, and basically what this is going to do is it's going to create a new pipe. It's going to create a pipe where the first element of the array represents the read end, and the second element of the array represents the write end. So if I call write using the write system call to the file descriptor that is now stored in the second element of the array, then I can read from the file descriptor that is now in the first element of the array, and that data will be there. Now I'm checking right here if it is less than 0, because if there's an error, pipe will return a negative value. And so that's what I'm testing here. And if it fails, I'm just going to return the current result like this, and that's going to basically return a bunch of null pointers, and so we can check that, detect that it didn't work. So at this point, like I mentioned, we have a pipe. We can write into the right end of the pipe, and we could read out of the read end of the pipe. But some of you are saying, what do you mean it's a pipe? It's just 2 ints. Well, they're file descriptors. When you call open to open a file, the kernel gives your program an integer, which represents that file. When your program wants to read from or write to that file, you tell the kernel that you want to read or to write to the file associated with that integer, that file descriptor, and it makes sure that that it gets to the right file. So here, things are really working in the same way. So as I said, now we have a pipe, but this pipe currently doesn't go anywhere. And we really wanted standard out. We really wanted to grab standard out. We didn't want to create some pipe that goes nowhere. And don't worry, I'm getting there. But in order to get there, the next thing we need to do is to come down and actually create a child process by calling fork. So I'm going to do it like this. I've talked about fork in a previous video. Check it out if you've never seen fork before. But fork is basically just going to clone the process. Okay, and I'm actually, now that I'm thinking about it, I'm going to use vfork instead. They function the same way roughly, definitely for this example, but vfork will be a little faster because it does a little bit less than fork, and that's okay because we're about to call exec anyway and replace this process. So once this runs, if it's successful, we're basically going to clone our process. Now it might not be successful. So very first, let's check a couple of cases. The first one is, did we have an error? So if this is negative, we know that something went wrong. We have an error. This is our error case. And so here, what I'm going to do is just close. We got to close this pipe down. You know, we got to clean up after ourselves here. And we'll come down here and yeah, we'll close out both ends, the read end and the write end, and then return result. Okay, pretty straightforward. Okay, now we have some conditions we want to check. Now that we know that fork succeeded, we need to check to see if we're the child. So if PID equals 0, then we know we are the child process. So we need to add some code in here. Now this is where things get a little interesting. We cloned the processes, meaning that now they each have a copy of those file descriptors. And the child process is the one that's going to run our command, and we want to connect the standard out from the child process to the right end of our pipe. So we're going to do this like this with the function called dupe2. And we're going to pass in stout pair, basically the right end here of our pipe, and we're going to duplicate it on top of standard out file now. Okay, now I have to admit, when I first came across dupe 2 years ago, I found it pretty confusing. But basically, what it's doing here is duplicating the file descriptor. That's why it's called dupe. And it's duplicating it onto another file descriptor. So maybe a more intuitive way to think about it is that it's taking the right end of the pipe and it's reconnecting it to standard out. Okay, so after this call, if I write something to standard out in this child process, it's going to end up going into my pipe, just like if I wrote into the right end of the pipe. So once we have that, then we just need to come down here and close the right end of our pipe, because we don't need it anymore. We've duplicated it. And the child process isn't going to read anymore from the read end, so we can basically just come down here and close the read end as well. Okay, so this just closes my local read end because this process is never going to read from this pipe at all. It's just going to put stuff into this pipe. Okay, so now at this point, we just need to run the command. Like I mentioned before, we're going to use exec. We'll use exec L specifically because I don't need to do path searching. And we could pass in the name of our test program right here. I'm not going to because I want it to function like popen does. I want to be able to pass in any shell command into here and have it work. So we'll use bin sh, that's the path to my shell. The first argument to any program is always the name of that program. So we'll pass in sh. And then we'll pass in a couple of arguments. Let's use -c, which tells it there's a command coming. Then we're going to pass in the actual command, and then you always have to end with null. So what this is going to do is it's going to run the command that we specified in its own shell. So if exec L works, then we're done. Like nothing else is going to run down here below, okay? But if there is a problem, if for some reason there's something wrong with the command and exec L doesn't work, then we actually do need to exit, and I'm going to pass in 127. That is a special exit code that stands for command.found, at least on Unix style machines. So that will ensure that if we do have any errors, the child process basically just bails, it aborts, and that's the end of things. So now let's jump down. Now we need to deal with the parent, because now if we ever get down here, we know we're in the parent code. And here there's not all that much to do. What I'm going to do is I'm going to set result.out. That's part of my standard pipe struct. So I'm just going to set its out element to the result. And here I'm going to call fdopen. Now fdopen is interesting. What it does is it takes a file descriptor. So we're going to use the read end of our file descriptor. Remember, we're on the parent side now. So the parent side is the one reading the output. So the other end of that pipe that we set up in the child. And what we're doing is we're setting it up to read. So what this is going to do is it's going to return a file pointer for the end of our pipe. And so that allows us to use things like fread, fwrite, fprintf, fscanf, and fclose. So we can use those functions instead of just using read and write. So it's really a convenience thing. We could just return the file descriptor if we wanted to, but I like this a little better. So then, because this side is never going to write into this, we're going to just close the write end. So this is the right end for the parent process, and we're just going to close it out because we don't need it anymore. And then down here, we simply return the result. Okay, so that's going to return the result we got, and really that's all there is to it. This will get that result struct back to the user, and this should work. Let's just make sure that it works. So let's go back to our test program here, to our popen3 example. Okay, we got this. Let's make sure it all compiles. It does, great. So let's try to run our popen3 example and see if this works. Sure enough, it works beautifully. And so now we got the same result as before. So now we just need to extend it so that it works with stdin and stderr. So no problem. Let's jump back into our popen3 function. Let's go back up to the top. And here I'm just going to create a few more pairs here. Make one for stderr and one for stdin. Okay. And we're going to need to create pipes for these two. One for stderr here, one for stdin. Okay, so we're creating a pair for each of them. Now, one thing that is different is if this one fails, we don't just return the result. We need to actually close out the stdout pair. So we basically need to clean that out. Now, this is going to get a little annoying. This is going to get a little messy. There's going to be a lot of these closing of pairs. And so let's maybe simplify things just a little bit by coming up here. Let's make a function called cleanup, and we'll pass in a pair of like a pipe pair. And then here we will just close pipe pair 0 and pipe pair 1. And this will allow us just to come down here and clean up things just a hair. This code's still a little repetitive, but it's okay. And then if stdin fails, then we will need to clean up both stdout and stderr. And let's come down here, and if we have an error down here, let's refactor this as well. So clean up our pair here. Here we need to clean up all 3. Just a lot of cleanup. Maybe this is why pout only does 1. Not sure. But now we can come down here, and here we've got one more thing to refactor. I want to clean that up, and we're going to do the exact same thing we did here, but with stderr. So again, we're duplicating the right end, and I got to make sure I get this right. Let's clean up stderr. And then we need to handle stdin. Now, stdin is going to be slightly different because stdin is input instead of output. And so we're actually going to duplicate the read end of the stdin pair. And we'll change that to in. So that sets things up in the child process. Now let's jump down here and let's basically do the same thing we did down in the parent, but with our new pipes. Let's change stderr here. Make sure I get this right. And then stdin. Again, we want now the right end of our stdin, and this is going to be a writable file pointer. And then we want to close the readable end. Okay, so this should work fine. Of course, should is a strong term. Let's make sure it actually does. Let's go back to our example, and I want to change it up in a few ways. So the first thing I want to do is remove the first part of the command because now I have a pipe. So I actually want to use that pipe to write that in. So let's come down here and fprintf. And we'll use mypipes.in. So that's the pipe that we're actually writing to. And I'm going to write in a string. And this should do nicely. And we also want to come down here and duplicate this. So we grab basically everything going to stderr as well. And so in this case, we're reporting stderr just like we report stdout. And so let's come down here and we're going to compile it. Okay, that looks like it worked okay. And now if we run it, you notice that it hangs. And so this brings up another point. You really have to be careful when using multiple pipes. It's very easy to put your programs into states where they're going to hang. So in this case, the problem is that my test program is still waiting for more input, so things get locked up. It doesn't know that I don't have any more input to send it, so it's just sitting there waiting for more input. So let's come back in here and let's change things up just a little bit. All I'm going to add here is I'm going to close the input pipe. And that's going to basically send that end of file message to it. It's going to say, hey, look, there's nothing else in here. So that tells it we're really done. Okay, so now we can come back in here and we can compile, still okay. And now if we run, everything works beautifully. The message we wrote into the test program stdin comes back to us just as we wanted it to, and we also get the standard error messages as well. Now, of course, there are other issues that you can get into with pipes relating to buffering and limited buffer sizes. And let me know if you want to see more about that in a future video. But for now, I hope that helps you understand better how pipes work and gives you some new tools to interact with other programs, processes, commands as you work on future projects. So that's all for today. Like this video if it was helpful. Subscribe if you don't want to miss future videos. And until the next one, I'll see you later.